This video tutorial is about the databases with documented metabolism in QSAR Toolbox and how we can analyze the information stored in them. As you learned, QSAR Toolbox provides functionalities to assess the possible metabolic transformation of analyzed chemicals. For this purpose, it uses the metabolic simulators, which are located in the profiling section, under the list of simulated metabolism/transformations. The simulation of metabolism is an important part in the read-across analysis for many endpoints, particularly those associated with human health hazards, because in many cases the toxic effect is due to metabolic activation of the parent chemical. To learn more about the workflow for read-across assessment considering the metabolic activation of the chemicals, please watch tutorials 19, 20, and 21. Along with the metabolic simulators, there are also several documented metabolic databases which are located under the documented level. The databases with documented metabolism in QSAR Toolbox are created using the MetaPath platform. To learn more how a MetaPath database containing documented metabolism can be imported in QSAR Toolbox, please watch tutorial 31. Now let's get started. Several new implementations have been done in version 4.8 of QSAR Toolbox specifically related with the documented metabolism. One of them is the ability to load and analyze various metabolism information from a database with documented metabolism. This tutorial demonstrates how to load and profile a metabolism database and how to visualize the metabolic maps. In another tutorial, we are going to see how to extract specific metabolic information such as quantities, species, and toxicological data if it is available for the loaded substances. To do this, we go to Input and click the Metabolite Database button, allowing to load a metabolism database. It opens a list of the currently available databases with documented metabolism. For the purposes of current example, we are using the EFSA Residues public database. It is not provided with the installation and users need to install it. The EFSA Residues database is available as plugin in the repository website. To install it, you have two options: to go to the Toolbox repository website and download it manually. After that, you need to install it using the repository client or directly to use the repository client. More details on how to install plugins from the repository website you can find in tutorial 14. Once the EFSA database is installed, you see it in the list of documented metabolism databases. Select it and the substances appear in the data matrix, and these are the parent substances. Now, we are going to profile and substances and extract the metabolites of the loaded substances. For this purpose, we go to Profiling section and select a profiler metabolic database affiliation and click the Apply button. This profiler indicates parents and metabolites that belong to the databases with observed metabolism. We can apply this profiler to any list of substances loaded in the data matrix. We use the profile statistic functionality to see the summary of the profiling result, where we can select a specific list of substances to work further. As seen, some of the substances are presented as metabolites in the database, and if we are interested to analyze these substances, we select the corresponding row indicating the substances as metabolites, and after that we can add this list in a new document. Let's go back to the document where the EFSA database is loaded. Now we are going to extract the metabolites for each of the substances. For this purpose, we apply the EFSA Residues public from the documented metabolism/transformation section. Before hitting the Apply button, unselect All in the profiling methods. Now, we see the number of metabolites as a result for each of the loaded substances in the data matrix. Double-click on a cell with result opens a table with 2D structures of the metabolites. Now, let's open a metabolic map. First, right-click on a cell with result and it opens a menu. Select EFSA Residues public, the name of the documented metabolism, and from the second menu select Show Metabolic Map. A dialog appears summarizing the metabolic maps for the current substance. Here we see also the unique number of metabolites for each of the maps as well as information about the test organism, species. Let's select map 14, which is associated with goat organism. Now, we see the metabolic map on the left part of the window and additional information related to metabolism studies on the right part of the window. The first substance, at the top, is the parent chemical. Selecting a 2D in the map shows details about the selected substance on the right. Here, we see information for the quantities, treatment groups, study summary, and data tables. Let's go back to the data matrix. Here, along with the profiling result, we can also gather experimental toxicity data for the loaded substances. For this purpose, we need to select databases. So, let's go to Data section and select all genotoxic databases. First, we need to select the genetic toxicity level of the endpoint tree and select all green databases. After that, click the Gather button, select genetic toxicity level, and we see the genotoxicity data for the loaded substances. The profiling result along with the experimental data can be exported and used for other purposes. Please watch tutorial 12 for more details. Congratulations! You now know how to get metabolic information from a database that contains metabolic information. More examples are coming soon. Stay tuned. Contact QSAR Help Desk for technical questions. If your question concerns policy or regulatory acceptance of Toolbox results within EU regulations of ECHA's competence, please refer to the ECHA website directly.